Hello and welcome back. So continuing on in this video, we should be able to get wrapped up the patch updater.
Right. There's two methods we need to finish up with this particular, or that we're going to finish up in this particular video. One is going to be the update method itself. That's the method that's going to run every frame, and it's going to check to see whether or not this patch should be visible to the camera and whether or not it is going to remove itself if it is outside of the range or our hold range that we've defined. It will also go through and do a collider check, which will be our second method that we're going to be implementing in this video. That collider check is going to check basically the distance of our character from a patch and then decide whether or not it's time to create a mesh collider for that patch. So let's get started with the update method in this one. So this will be simply void update. And inside of here, we're going to look at our patch.render.enabled. Now, to do a test to find out whether or not this is going to be visible in the camera, we're going to leverage the power of geometry utility. It's got this really cool method called test planes AABB. This is basically just a bounding volume check, and it's going to check the bounds of our patch against the frustum planes of our camera, and if the two intersect, this will be set to true, and if they don't, it'll be set to false. And I'm going to use that to toggle our the renderer of our patch. So we can call on our camera utilities, and inside of camera utilities, I set up some planes. Those are our planes that gets calculated every time the camera runs through that update. And I'm going to check those against our patch.render.bounds. So just determining whether or not we're going to be drawing a particular patch is as simple as that. Not a whole lot to it. So the next part is going to do a distance check, because while it is cool to be able to toggle the patch visibility based on the frustum, I also want to deal with the case that, it's not perfect. You can get yourself in a position where the camera is just right and a patch that is close, or where the edges are close to the player themselves, that patch may not be visible. So what I'm going to do is a second check that is going to ensure that any patch that is within, a 9 patch unit or within a distance of 2 is going to be visible automatically. So basically wherever the character is, and those 9 patches around that character will always be visible, regardless of whether or not the frustum or the camera frustum can see them.
Right.
So we'll do that with a vector2.distance check. So we'll say distance. We're going to get our offset of this particular patch. We'll check our camera utilities dot get current patch, and we'll check to see if that is going to be not greater than but less than or equal to 2. So this will set our distance. If that is true, then we're going to say patch.render.enabled is equal to true. All right. So that is going to be our first check. Now these I want to happen every single frame, because it is possible to really start spinning the camera very quickly, and I want to make sure that this particular check gets done every frame. Now the next checks are going to be checking whether or not the collider needs to be added and whether or not we're going to destroy a patch when it's moved outside of the range. These checks aren't as crucial to be done on every frame. So what I'm going to do is put in kind of like an early out. That's going to say time.frame count modulus 30 does not equal 0. So every 30 frames we're going to run this next check. Otherwise we're just going to kick out. Now the next check we're going to do is going to be checking to see if we're outside of our hold range, and if so, we're going to destroy this patch. So we'll say if vector2 dot distance, and we're going to check our offset again. We're going to check our camera utilities dot get current patch, and we're going to see if we're greater than, and I'm going to wrap this because we're running out of room here. So wrap that and check it against our camera utilities dot hold range -1 and divide that by 2. So if that is true, we're going to destroy this patch. And what don't you like? Possible loss of fraction? No, I don't care. That's no big deal. All right, the next thing we need to do is our ColliderCheck. And we do not have this method yet, so we're going to create it. Now, our ColliderCheck isn't too difficult, but it does have some mesh in it, or some mesh. Nice. It's going to have, yeah, some math in it. So I was reading the first slide I need to type in. It was mesh. It's like, oh,
Gotcha.
great. So this is going to basically say if mesh collider does not equal null, we're going to return. Basically, if this patch already has a mesh collider, there is no point in doing this check. Get out of here. Just carry on, do whatever you were doing before. The next thing we need to do is look and get the point where our character is standing. Now, I'm leveraging the fact that I'm using our third-person character system, and our camera utilities has that target look at object. So if you're using a different system or a different type of character setup, you're going to have to modify this section of code to work with your particular setup. So it may not work the same as mine is. But basically all we're doing is we're trying to get the location in of a 2D vector, meaning I don't care about the Y location of our character, but I do care where the character is located in X and Z. So as long as you've got a means of figuring out where your character is relative to that, everything's good. So we're going to use camera utilities target lookat dot transform dot position dot x, and camera utilities dot target lookat dot transform dot position dot z. So this gets our target point or character point, whatever you want to call it. The next thing we need to do is get our distance. So I'm going to say var distance equals a vector2 dot distance, and I'm going to check between our offset of this particular patch times camera utilities dot patch size. Now you got to remember our offset is in offset positions of our patches, meaning one patch directly to our left is a -1 unit away. While in reality, or world space, not so much reality, this is a game after all, but in world space, that isn't going to be, 1 unit to the left. It will be whatever our patch size is to the left. So we need to multiply our offset by patch size so that we're compensating correctly, because our target point is in world space, not in unit spaces. So that will give our distance. And then we'll do our check that says if distance is less than equal to our camera utilities dot patch size. Whoa, that didn't work right. Dot patch size. Now here comes that magic number again that I went through a couple videos again and explained why it's not really magic. That's at 0.707. So I'm going to multiply our patch size by that number. That will give us the distance from the center of a patch to the farthest possible corner of that patch. To that, I'm going to add a little bit of fudge factor. Before I had rounded that up to 0.8. But in this case, I'm going to use camera utilities dot patch size times 0.1, or 1/10 of our patch size. Okay, come on. And then from here, if we need to add our patch, we're going to say start code routine, add collider. So go ahead and build that out, see if we have any errors. There's no errors. So if everything works, I'll be amazed. But if it does work, then we can start playing around and testing this with some data that we've baked out ahead of time in the upcoming video. But let's see what happens. So hit play. We fall right through the world.
Are you actually applying those, or is that code still commented out?
Hey, you know what? I bet it's still commented out because we didn't exist that. Good catch. Train manager.
There we go.
Dink, dink. All right, let's see what happens. Oh, didn't work. Hold on. Let's see if this is being applied. Train mesh.
Nope.
Sure, nope, not working. So
Make sure
they're built.
Yep.
Built and recompiled. So there's this. Go ahead and hit F6. Go back over here. Our first visual test is we should have a texture on it. But trim system here. Trim manager. Scroll down. And yeah, it's not commented out there. Let's see what happens. Hey, look at that.
There we go.
So, well, that's kind of interesting. That little flickering that's going on.
Yeah.
What that's all about. Oh, I do know what that's about. Config any. Because the numbers were the same.
Mm-hmm.
What's happening is it's going, hey, you're greater. Remove it. It goes, oh, no, you're in my interest range. Load it.
Right. Much better.
Yeah, there we go. So now we can bring it all up. All right, so we have colliders. We're not falling through the world. We don't have much in the way of lighting. You know, we could fix that. That's not too hard. Create other, directional light. Hey, look, we've got light. Let's put this at, let's say 45 by 60. Let there be light. There, now we got some light in here. So now we can run around. And our textures look horrendous, but we haven't really dialed them in either, so I'm not too about it. All right, so in the next video, we're going to be playing around with this a little bit more with some data that we've baked out already.
Yeah, where we actually have a little bit more data than just a few patches like this.
Yes.
Okay, so with that, that is going to wrap up this video, and we'll see you guys in the next. Thanks a lot.